All right, good evening to everyone. This is Amateur Radio Roundtable. It's a show about ham radio. If you're listening out there on shortwave on WBCQ on 7490, we welcome you to this ham radio show. You know, a lot of us got interested in becoming ham radio operators just by listening to shortwave, just like you're doing tonight. So send us an email if you're out there listening on shortwave. I'd love to hear from you. Send it to Tom at w5kub.com. Tom at w5kub.com, and hey, we'll get your QSL card back to you from the 7490 shortwave station. I want to ask everybody if they will, hey, please hit the subscribe button. If you have not subscribed to the channel, that helps us out greatly. Hit the subscribe button. Hit the notify button so you'll know when we do come on live. Sometimes we come up during the week with some type of special event, and it would notify you. So hit that, hit the like button, hit all the buttons on there if you can, and that'll greatly help us and help YouTube to advertise our show. You know, hey, we got a special announcement coming up here, maybe in about 15 or 20 minutes, 25 minutes. So don't go away. Got some great news to pass on to you guys there. Let's see what else is going on. Let's jump around the room here and just see who's in the see who's in the room. I think we got Alan up first. How you doing, Alan?
I am here. Hey, good evening. Good to see you all. I know I've been out a couple of times, but work's been picking up here. So it's good to be back, and had an interesting weekend, and also got an interesting week coming up here. But I thought we'd talk a little bit about oscilloscopes tonight, or at least one topic about scopes. Talk about probing, which is probably one of the most important topics in terms of getting signals into your scope properly. So yeah, that's what we got on tap for tonight.
And I could sure use that. Hey, while we're at it, I heard that you received the 2020 Hudson Division Technical Achievement Award, right? Hold that thing up. You got the plaque here? Let's look at it, man.
So I was going to get that on camera there.
We got it there, man. And you were rubbing elbows with some big wigs there, Joe Taylor,
yeah, it was the Hudson Division. It was a Hudson Division awards luncheon. And, because I guess we're located pretty close to Connecticut, we actually had the ARRL CEO, NA1AA or NA2AA, Dave Minster was there. And also one of the other award recipients was Dr. Joe Taylor, K1JT. He received from the ARRL, not just the Hudson Division, the 2019 Technical Achievement Award for JT8. One of the many digital modes he's developed. So this is a photo here of me, along with Dave Minster, AA2AA, the ARRL CEO, the Nobel Prize winning K1JT, Joe Taylor, Dr. Joe Taylor, and then this is WO2X. David was the 2021 Hudson Division Technical Award recipient, and also received the 2021 or 2020 Cover Plaque Award for his work with Node Red for doing remote station operating. So I shared a table with these guys. So it was a really fun evening.
Well, that's so cool there, and hey, those guys have done a lot, man. I don't know how they do this. I guess they're just smart, right? That's what it is. They're just smart.
And, we'll have to talk with Dave. Yeah. Maybe we can get him on because Dave, he's done a lot of work with remote operating, and he'll tell the story about why he actually had to do it out of necessity for a while, but and it's kind of been involved in this thing called Node Red, which allows you to control relays and power switches. So he has his entire station, including being able to cycle power on everything from his rotors to amplifiers to radios to everything else, all remotely. So it's actually really cool.
Wow. Well, yeah, let's get him on here and have a good time and talk about it. I'm sure I'll learn something for sure. Hey, let's jump over and look at. Let's talk to Glenn. Hey, Glenn, how you doing?
Hey, I'm hanging in there, man.
All right.
Finally got something put together for tonight.
Okay.
Going to be talking about PC board design software a little bit and how to do it and what it looks like.
Is that using some type CAD program, or is it called CAD?
Yeah, we're going to be talking about Eagle PCB.
Eagle. I've got Eagle here. I've tried it a couple times, and boy, it's just complicated for me. I want to learn about it because
it's a little tricky to learn, but I've got some very good solutions to help you get around that. I mean, I brute forced it. I had to use it for all of my books. And, it was just kind of trial by fire. Well,
look, here's what I like to do. Hey, and there might be a simple way to do it, but I build these little trackers here, and they use 0402 parts. The parts are the size of the end of a needle. And I would like to expand this up to 0604 parts. Same schematic, just use the little bit larger parts. They're still pretty small, but they're easier to work with. And
you should be able to do that.
I've got the board. I've got the board layouts, on Eagle. I just wish there was some way to convert it to, the next larger, expand it somehow.
You would have to replace each part individually with the larger part.
Yeah.
Just change the part and tell it to redo it and rework it.
Wow. Well, okay. Well, it sounds simple. I just don't know. I don't know. Well, okay. Well, very good. Looking forward to that tonight. And we maybe we'll learn something tonight on that too. Boy, tonight's going to be a learning experience, I think, for us. Okay, so let's see. Let's just jump right into the program here. Oh, let me just say hello. We got a couple of new people in the chat room, I think. There's a NA5C Steve in McAllen, Texas, on here tonight. We'll say hi and do a shout out to Steve down here in Texas. Is there anybody else new tonight? We advertised the show somewhat on some of the Facebook groups, and it may have brought some new people over here to the show tonight. So just interesting to see if we have any new people on the show. I know we probably had 20 or 30 people join the Facebook group. So I don't know. I'm sure we got some new people tonight. And let me just mention that, since I brought up Facebook, we've got a great Facebook group, guys. It's called Amateur Radio Roundtable, but that's a really long name. And if you'll just put in W5KUB in a search in Facebook, it'll bring it up. It'll bring our group up. We have over 12,000 hams in our group, and it's a very active group. A lot always goes on in that group, so please join us, and everybody is welcome. Join us on Facebook, W5KUB. All right, so let's see. Hey, Alan, talk to us about scopes tonight. Let's just jump right into it.
Yeah, did you want to mention the international flavor you've got coming up before I get started?
I will do that, and I should do that. I think I briefly mentioned it in the opening, but guys, in about 15 or 20 minutes, we're gonna have a special guest on the show from Russia, and she has joined our team and has some great video and is a great ambassador for ham radio, and I think you're really going to enjoy it. So stick around, and after Alan does his thing, we'll be bringing in R1BIG. So stand by. Okay, go ahead, Alan.
Alrighty, very good. Hey, we're looking forward to Raisa coming on here and see what she's got for us. So actually, it's interesting. I had my oscilloscope up here for a program that I worked on Friday, and thought it might be good to kind of redo some of that for the audience here, because many of us have got oscilloscopes, and one of the most important things when using a scope, especially when you're probing around in circuits and things like that, is the proper use of probes. Okay, and what's interesting is that there's some subtleties there that people may not know. And one of the most of the probes that folks use, they kind of look like this sometimes, or you might have some older ones that got a different style. We'll call it a comp box that plugs in. Most of these probes are called 10x probes, and many people don't know a whole lot about why they're called 10x probes and why we actually use 10x probes. So I'm going to briefly cover that and then show one or two good best practices with probes. So let me do a quick little share here to help you guys better understand what 10x probes are. Okay, so if we look at this, this kind of little simple RC circuit over here, this is essentially what the input to your oscilloscope looks like. Typically a 1 megohm resistor to ground, and that's shunted by some amount of capacitance, usually somewhere between 10 and, say between 10 or 15, 20, 25 picofarads or so, depending on the bandwidth of the scope. Higher bandwidth scopes is going to be a little bit lower. The lower bandwidth scopes is going to be a little bit higher. So how do we connect that input to our signal, or to our board? How do we connect it up to the circuit? Well, why don't we just use simple wires, right? And we just use flying leads like we do with the DMM. Well, two things to think about. Number one is that one side is always ground, okay? So you always have to connect one end to ground. It's not like the leads of a DMM, okay? So one side's always ground. So, okay, so I'll connect one wire to ground, then I could just have another wire connecting up to my circuit. Why doesn't that work? Well, part of the problem with that is that these long wires and the big loop area adds a lot of inductance into that measurement path. And inductance presents a higher impedance at higher frequencies and can cause some problems. And more importantly, that big loop area is going to look like an antenna. It's going to pick up all sorts of noise and things like that. And the wires could also couple your circuit's signal to other parts of the circuit. You can get away with this generally for low frequencies or very large signals, or a combination of both those two actually, but not really much more than that. So we generally don't use flying leads for anything more than, audio basically. So how about we solve some of that problem by making it a coaxial cable connected to the BNC connector of the scope and connect that up to our circuit. Okay, well, the good thing about that is that, we've minimized that stray pickup because we've shielded the line that we're using to pick up our signal, and that minimizes coupling to other parts of the circuit, so that's good. The bad thing, though, is that we've added capacitive loading, okay, because coax is, tens of picofarads per foot. And very easily, a hunk of coax, connected up to your circuit could look like 100 picofarads. Now, how's your circuit going to react to 100 picofarads hanging on that node that you're trying to measure? At 30 megahertz, 100 picofarads is about 50 ohms, right? So it places a pretty heavy load on your circuit. So while we've solved one problem, we really kind of introduced another one by doing the shielded. So let's see how we can address that. Well, let's say if we take that hunk of coax and let's stick a series resistor in series of the signal line on the far end of the coax. What that does is it isolates the probe capacitance, or the cable and scope capacitance, so it puts that 100 picofarads on the other side of a 9 megohm resistor. So that kind of takes it out of the picture, so that's a good thing. It attenuates the signal by a factor of 10, right? 9 megohm resistor here, 1 megohm resistor over here, right? So we created a 10-to-1 voltage divider, okay? But in many cases, we can deal with that. And this is part of why this is called a 10x probe, because of that 10-to-1 voltage division. But we've introduced another problem, all right? At very low frequencies, right, the voltage division is handled pretty easily by the 9 megohm and 1 megohm, right? That's your 10-to-1 voltage divider. But as the frequency starts to go up, the reactance of this 10 to 20 picofarad capacitor at the input is going to start being lower than 1 meg. And when that happens, you essentially now have a 9 megohm resistor in series with, or shunted, with a shunt going down that's less than 1 meg. So you've essentially created an RC low-pass filter. So now we're filtering away our high frequencies. So we got rid of the capacitance, but we still have now a low-pass filter. and that gets worse as the frequency increases. And it's really only at, tens of kilohertz where that starts to matter. It's like, oh, shoot, well, that didn't really help me, right? So there's one more thing we can do to counteract that, okay? And that simple fix is to put a capacitor around that 9 megohm resistor. So now at low frequencies, the 10x voltage division is handled by the resistors. At high frequencies, the capacitors take over and it becomes a capacitive voltage divider. And the only thing we have to ensure is that, while these resistors have a 10-to-1 ratio, these capacitors have to have a 10-to-1 ratio. It's actually in the other direction, but it's still a 10-to-1 ratio. And therefore we can get essentially a capacitive voltage divider that gives us the 10x voltage division at high frequencies. The resistive voltage divider gives us the 10x division at low frequencies. Oh, great, we're done. Well, almost. The problem is that, remember how we mentioned that the input capacitance to the scope is somewhere between 10 and 25 picofarads. Well, that varies by scope, which means I can't just pick a capacitor value to stick around that 9 megohm resistor and have it work all the time, because it's got to match against that. So we make that capacitor variable. And the process of adjusting that capacitor is called compensating the probe. And this is something that new and novice scope users and experienced scope users alike often forget to do. So we're going to talk about how to do that and what it looks like. Okay, so let me unshare this screen here. And I'm going to go and switch my camera now, get fancy on you, and switch over to my oscilloscope camera here. All right, so here's the typical 10x probe. Okay, this is a Tektronix P6139. It happens to be a 500 megahertz 10x probe. And here's my little witch's hat, the clip lead on the one end, and my ground lead. Okay, and here you'll see a little hole here, and it probably won't focus in on this. It says probe comp. This is where you actually make the probe compensation. And when you get your probes, you also get this little screwdriver doodad. How many of you know where this is? Right? Make sure you go dig it up and go find it. Because as I mentioned, that the compensation is important with its frequencies as low as just a couple of kilohertz. Your frequencies above that will be either reading high or low if you don't have that compensation adjusted properly. So let's actually plug this scope here, or plug this probe here onto channel 2 of the scope. All right, and I'm going to turn on channel 2. I'll turn off channel 1. And I'm just going to quickly set my trigger to trigger on channel 2 so we can go look at that. Now, because on just about every scope in the world is a probe compensation or probe calibration signal. It's called probe cal or probe comp. On this scope, it's way over here. So I'm going to connect up the ground lead to ground. I'm going to connect up the trigger loop or the scope to the compensation signal itself. And let's scoot this down here, adjust my trigger level up, and scoot this down. And now this probe compensation signal is generally a 1 kilohertz square wave. Now keep in mind that it's not exactly a kilohertz. It's not designed to be a 1 kilohertz frequency reference. It's just an approximate 1 kilohertz signal. And the reason we use that is that the 1 kilohertz fundamental frequency is slow enough that the resistive voltage divider will give you the 10x voltage division. Okay, but it's got high frequency edges or fast edges, so there's a lot of energy at much higher frequencies that's going to be affected by the capacitive voltage divider. So if we go in here and stick the screwdriver inside the probe, and if I get that to kind of settle into the right spot here, there we go. Now we can see if I have this probe misadjusted, I could be undercompensated, and this is where the capacitor around that 9 megohm resistor isn't big enough, and I'm low pass filtering the edges. Okay, or if I adjust it the other way, that capacitor is too big, and I'm passing too much of the high frequency energy, right? So that I'm getting less of a voltage division at the high frequency at the edges. Okay, so the idea is that you want to adjust that probe compensation to get as close as you can get to a perfect looking square wave. And now you've matched that probe to the input capacitance to your scope. And again, a pretty important thing to do, because without doing that, the measurements that you make at signals above just a couple of kilohertz can be off, either by being either too high or too low, and you wouldn't know why. It's purely because you didn't have the compensation adjusted right. So dig out your 10x probes and be sure you properly compensate them on your scope. So that's the first topic I want to talk about. That's one of the number one best practice thing that you want to think about when using 10x probes on your scope, is to properly compensate them. It's amazing how many people, even professional engineers that have been doing this for years, don't know where their little probe adjustment tool is, and can't remember if they've ever compensated their 10x probes or not. So go ahead and do that. The next thing I want to talk about, and probably the second most common thing that people don't do right when it comes to, or don't think about enough when it comes to looking at their using probes, is properly setting up and properly adjusting, or properly using the ground lead, and paying attention to that ground lead length. So we look at this probe, okay? So this is the business end of the probe, right? I can pop off the little witch's hat, and there's my little probe tip, right there. The witch's hat kind of gives me the little spring hook on it. And then I got a 5 or 6 inch long ground lead here. But remember what we said about leads, like flying leads? Well, this ground lead also adds inductance. Now, remember the input to the probe tip, it's got some capacitance to it, right? And now I've got some inductance in this ground lead. Well, what happens when we couple inductors and capacitors together? Well, we create a tank circuit, right? That tank circuit can ring, right? It can cause problems. So let's take a look at what I've got here on the scope screen right now. I'm probing on this little board I've got down here. It's a little demonstrator board that we use for demonstrating various features of the scope. And I'm probing a little pin down here that's actually a 2 nanosecond wide pulse. It's a very, very narrow 2 nanosecond wide pulse. And I'm using that 5 inch ground lead on this probe. And if we take a look at the scope screen, I can see that 2 nanosecond edge. And I see all this little ringing going on down here. Now, is that ringing real? Or is it just due to the ringing due to this ground lead? If I go put my fingers on that ground lead and move it around, I can actually change that ring a little bit. So most higher frequency probes are going to come with some additional ground accessories. And the one I'm going to show you here looks like this. Let's see if I can get this to focus in here or not. Let's see. So it's a little tiny spring. So if I can just put it on my palm. Okay, so it's a little spring that fits the probe, and I'll show you how in a moment, with a little bit of a tail on it. And the idea with this is that you're going to take your probe, okay? I'm just going to pull off the little ground lead here, just unsnaps off the side, okay? I'm going to pull off the little witch's hat. And if you look at the probe tip, there's a little concentric ground ring, a coaxial ground ring, right around the probe. So that little spring tip, or spring ground adapter, I'll call it, slips right on there. Let me see if I can get this thing to slip on here all the way. There we go. So it slips on there like that. So I get that to focus in. So now I've got my probe tip and a ground lead that's very, very close. And the idea is hopefully you've got a ground nearby to what you need to probe on the board. So now if I go down and I look at that same signal that I was just looking at before, let's get this guy in here. And now if we take a look at that, all that ringing that I had right here is now all gone. Oh, I slipped off my point here. Let's go put that back on here. There we go. So all that ringing is now gone. So now we know that all of that ringing that I was seeing for a good 30 or 40 nanoseconds after my edge was all simply due to the ringing of that LC circuit formed by the probe capacitance and that 5 inch ground lead. So when you start dealing with higher frequency circuits, the length of that ground lead can be critical in terms of making sure that your measurements are good and clean. You're not introducing any abnormalities and problems that you might have to go chase down. So those two things not properly compensating your probes and not really paying attention to grounds when you're looking at higher frequency signals are the most common things that people kind of get messed up with here a little bit. And the other one might be, well, hey, I'm probing this signal and it's 10 times bigger than I expected or 10 times smaller than I expected. And that's oftentimes when you've got an oscilloscope that doesn't recognize when you plug in a 10x probe. Some probes, like this one here, have a little indicator pin on it. Let's see if I can show that up here. See this little spring-loaded pin right here? And for properly equipped scopes, that tells the scope that I've plugged in a 10x probe, and it changes the vertical scale. If your probes don't have that, or your scope doesn't support that, if you've got a 10x probe, when you plug it in, you may have to go into the vertical channel of the scope and tell it what attenuation. If I go down here to probe setup, I might actually have to go tell it, for example, what probe attenuation I'm using so that the vertical scale reads right. But those are the most common things that will help you take you from a novice scope user to a power user. So anyway, that's what I had to share. There's a lot more we could talk about with scopes. I could spend hours doing it, but I thought that might be a good one to go, and we'll take a look at see if there's any questions in the chat that we can answer.
Yeah, I've got a couple questions. Go ahead and bring your picture back.
Yeah, so let me bring my scope back up. So it looks like, I'll work backwards here, I guess. So Russ R1BIG asks, does a probe need to be compensated before each use? The answer is probably not. If you've got one scope, like most people just have one scope, once you compensate the probe on that scope, you generally only have to do that once. It's a good idea to check it periodically, but it shouldn't vary much from channel to channel on the scope. But once you've compensated it once for your scope, you don't have to worry about it again generally. But if you've got two scopes or you have different probes, whatever, it's a good idea to make sure the probe is compensated for the scope that you're using. But it doesn't change over time, so you don't have to worry about doing that again.
Yeah, I've got a question too. I've got a couple spectrum analyzers. They have a BNC on the front of them.
Yep.
What type cable should I use on that? Just a straight through shielded type cable? Could you use a scope probe?
A straight through cable is certainly fine. The big thing you have to remember, Tom, is that the spectrum analyzer input doesn't have a 1 megohm resistor to ground. It's generally a 50 ohm termination. Right. So you really can't use a 10x probe like we're using here, because this 10x probe has got a 9 megohm resistor in series with the probe tip. So 9 megohm would then be a voltage divider against 50 ohms, which would be a huge voltage division, and you wouldn't get anything through it. Okay.
So that would be a big attenuator. Probably a really big attenuator, wouldn't it?
It look like a huge attenuator.
Yeah. Okay. All right. Well, that's good.
There are what are called low capacitance probes, or Z0 probes, which is effectively like the 50 ohm cable with a smaller resistor in series. For example, if you put a 450 ohm resistor in series, then overall it looks like a 500 ohm input, which wouldn't load a 50 ohm circuit as bad. It would attenuate the signal by 20 dB, but you could do that.
So are you talking? Were you
6150?
Were you talking about a time 10 probe or a time 1 probe?
Well, if you just take the 50 ohm coax and run out to the end, that's just a times 1. This is an extension of the 50 ohm environment. If you took a 50 ohm coax with a 450 ohm resistor in series at the probe tip that connects up to your spectrum analyzer, that would be a times 10 low capacitance probe for a 50 ohm environment.
So I guess my question is a lot of my probes have a little switch on them, time 1, time 10.
Yeah.
They may not be great probes, but so as a times 1 probe, it doesn't have the 9 meg and the 1 meg, does it?
No, it doesn't. In fact, the times 1 probe is effectively a straight through. However, most probe cables, the coax, isn't a pure 50 ohms. It's intentionally a little bit lossy. So it won't look like exactly like a coaxial cable, but you could certainly get away with using your
time 1 probe.
Your times 1 probe, but it's not generally a 50 ohm coax, so you're almost better off using just 50 ohm coax.
Okay, gotcha. Okay. Yeah. All right. Well, very good. That Somebody said it looks like I'm up on your shelf right now. Yeah. Oh, I don't want to fall. Oh, gee. Oh.
So,
All right. Well, hey, that's great news. I learned something tonight, and I learned about the times 1 and the times 10, and cool.
Very good.
All right. Well, hey, thanks so much for sharing that with us tonight, and we're looking forward to the next segment you do.
All right. Sounds good.
All right. So
I'll continue to look through the questions on the chat to see if there's anything I missed.
Yeah, go ahead.
There is, somebody asked if you have to do this for analog and digital scopes.
Absolutely, because so the nice thing, you have to do it for both. You definitely do. The newer digital scopes, like the one that I've got here, the probes that actually come with it can actually be compensated for by the scope, and then the scope remembers the compensation characteristics for that probe. But the vast majority, you still got to adjust manually.
All right. Well, very good. Okay. Hey, guys, just stand by. We'll be back in just a couple minutes here. Spice up your ham shack with ICOM's IC705. This portable radio is perfect for staying in or venturing out and working your favorite bands this winter. Happy holidays from ICOM. The IC705 is a perfect sidekick and QRP companion, base station, features, and functionality at the tip of your fingers in a portable package covering HF 6 meters, 2 meters, 70 centimeters. This compact rig weighs in at just over 2 pounds with RF direct sampling for most of the HF bands and IF sampling for frequencies above 25 megahertz. Some of the features include 4.3-inch touchscreen with live band scope and waterfall, sideband CW, AM, FM, as well as full D-Star functions, has a micro USB connector, Bluetooth, and WLAN, integrated GPS with antenna and GPS logger. The HM243 speaker microphone comes standard. The perfect accessory for the IC705 is the optional LC192 backpack. It has a special compartment for your IC705 and room for all your accessories. Our family of favorite ICOM amateur radios are also available this holiday season, and they make the perfect gift. Don't forget the 9700, the 9300, and the 7610 base stations, and the ID52A handheld coming soon. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, and we're back, and there was a question. Steve, one of our new people tonight, Steve, NA5C, had a question for you, Alan, about differences between expensive scopes and less expensive scopes.
It looks like, Steve, your question was the practical differences between the expensive tech scopes and the more affordable, like Rigol or Siglent or some of the other scopes that you find out there. And when you get down into what we can call the entry level and even hobbyist market of scopes, really the biggest difference is that, and I remember talking with our engineering folks about it, because Tektronix makes kind of entry level scopes as well, but they still don't cost as little as like a Rigol or a Siglent or something like that. So what's the difference? And I was told by them it really comes down to a couple of things: the amount of the engineering that goes into it, calibration, durability, things like that, and a lot of that comes down to choice of components. Things like the rotary encoders and switches that are used, on the Tektronix scopes and other like Keysight or HP Agilent or whatever. those components, the potentiometers, the switches, the rotary encoders, the displays, and things like that, are industrial rated components, which have a higher temperature range and a much longer service life than more commercial rated components that might be used in the less expensive instruments. So that's one difference, and that's part of the difference in cost. But there comes to calibration, stability. There's a lot of engineering that goes in, that way as well. But at the end of the day, for a lot of the hobbyist work that you're doing, you'll get, perfect service out of something like a Rigol or a Siglent or something like that on your bench. It's certainly probably more affordable than a brand new tech. But you could buy a used tech for a decent price and have a really nice professional quality scope on your bench. So. But otherwise, there is in terms of what the scopes do, there isn't a huge difference. It really comes down to durability, accuracy, reliability is what you're paying for.
All right. All right, very good. For any other questions, just put them in the chat room there, and we'll be glad to answer them. Was there anything else there?
It's kind of funny. I have got a hand tech, which is similar to the Rigol. That is my kind of day-to-day one. But when I want to get serious, I break out my ancient analog 475 Tektronix, because it's just easy to use and accurate and easy to set up.
Yeah, I've got a 465B in the basement that I use a lot, and I've got a couple of analog scopes in the basement, so and I use them quite a bit too. So I like them all.
Okay, so another question in here was about tuners, and I try to answer that. He's got one band that doesn't tune, and I think we did a show on this a while back on the tuners.
Okay.
Yeah, because most of the LDGs are rated at 10.
But I put up a chart that had links to stay away from, and it had it all laid out. And if you use this link, it'll work on all these bands, but it won't work on this band.
Exactly.
If you use this length, it will work on that band and that band, but it might not work on the middle band. And so it's real critical in there.
Just add 5 feet to the wire, you'll be good.
To try some different lengths. And he said he shortened it a little bit. It didn't help. You might try to lengthen it a few feet. Do 3 feet, 4 feet.
If we go back and remember a show that I did probably a while ago talking about Smith charts. A Smith chart is a way of plotting complex impedance and things like that. But one of the things to remember on a Smith chart is that the further the impedance is away from the center of that Smith chart, right, the higher the SWR is. And then with a given SWR, if you just change the coax length, what happens is you essentially inscribe a circle around the center, and that's called a constant SWR circle. You don't change the SWR by changing the length. However, what you do change is the impedance, right? There's an infinite number of impedances that can result in a given SWR, right? If your SWR is 3 to 1, there's an infinite combination of impedances, capacitive and inductive, that can give you a 3 to 1 SWR. A tuner may say, okay, the tuner is designed to correct for a 3 to 1 SWR, but it might have trouble on certain portions of that circle. So by adding or subtracting coax, you rotate around to a different part of the circle, change the impedance for that same SWR, and then you're able to tune it. So that's likely is what's happening, is that you're running into a corner case where even though the tuner's rated to tune a 10 to 1 SWR, it doesn't do so well if that 10 to 1 SWR is in a certain spot on the Smith chart. But by adding or subtracting coax, you can move it around, and then it may be able to tune for it.
Right. Hey, there's a question from Ed, WB5ORT. I'm not sure I understand it. What would be the array of probe a guy would need with an oscilloscope?
Well, I'm assuming that you mean, well, correct me if I'm wrong there, Ray, but I'm assuming you're meaning, how many different types of probes would I need? And for the most part, enough 10x probes one for each channel is probably all you really need. You might want to have one 1x probe or maybe a probe that can be switchable between 1x and 10x for those instances where you've got a low-level signal at a low bandwidth. But otherwise, 10x probes are 99% of the time I'm using just a passive 10x probe. So I think that'll be fine. One thing to remember is that another question I'll get all the time is, okay, I've got a scope that's rated to 50 megahertz, but I've got a probe that's 100 megahertz. Can I use that? Okay, and most of the time the answer is yes, but there's a caveat. Each probe can only compensate for a certain input capacitance range in the scope. So if you use a really high bandwidth probe on a very low bandwidth scope, you might not be able to get it compensated because there might not be enough range in that adjustment. So that's the only little caveat that you got to look at is it's perfectly fine to use a wider bandwidth probe on a lower bandwidth scope as long as it can be compensated.
Yeah, now one thing when you're also talking about the probes, in addition to the 1 and 10x probes, as you did with the spring ground clip, there are also small slip-on tips that have different aspects. So instead of the clip that comes on with the witch's hat, you have like an IC pin tip that will actually insulate both sides of the metal tip from the other IC pin, so you can scope down a circuit board without shorting anything out. So there's a variety of different.
That's a great point, especially when you start probing, small surface mount parts. That can be really important so you don't short things out. So usually the probes, when you get them new, come with a lot of really good and very useful accessories. So it's a good idea to take a look at all those little plastic baggies that come with your probe, because there's usually goodies in there that are there for a reason.
Yeah, and someone asked if there's a 100x probe.
There are. People do make 100x probes and even higher for high voltage applications. You don't find them that often, but there are 100x probes out there.
Wow.
I've got one or two in my basement. There are some that go even higher yet for extremely high voltage applications. There's also a lot of other specialized types of probes as well for probing differential signals and currents and things like that. So, but like I said, probably 99% of the time, a simple 10x probe will cover you for everything you want to do.
All right, guys. Well, let's move right along here.
All right.
But I finally found, I think, probably the most famous amateur radio operator. Her name is Raisa R1BIG. And let me bring her in here. No real big introduction before I bring her in, because we're going to talk with her and let her kind of tell us a little about her, or a lot about her. So come on in and let's talk. And boy, we are so happy to have you tonight. This is your first time on the show.
The audio is not going to feed through to you. You're going to have to watch it on the
Thank
web.
you so much for joining us.
Hello, Tom. Hello, everybody. Thank you so much for your invitation. It was a great pleasure to me, and I'm very excited to be a part of your great show. Thank you.
Well, I am so happy to have you on our show with us, and it's going to be just great. I've looked at your videos and your blog, and you really do a lot for ham radio. In fact, some of us old timers have not done as much as you've done, and you're a relatively new ham. You've only been a ham a few years, but you have done so much. Tell us, why did you get your license? What did you think about when you got your license? How'd that happen?
I was licensed in 2018 in December. And my first cursor was in the May 2018, and I was so exciting. It was only the first time, and I was very surprised. It was a man from Moscow, and I decided that it could be a very interesting hobby. And then I tried to preparing for the exam, and I passed it in December. and during this time, I was so involved in such a great hobby and knew so many things about it. And I am a person who like to share with something good. For example, if I tried something new and I like it, I always would like to share this thing with my friends. And I thought that it would be a good idea to show my simple steps in this hobby, and maybe it brings new people to the hobby, and especially I am thinking about whales, and I hope that we will hear many whales in the future on the radio waves.
Well, you know, I'm looking up the numbers, only about 15% ham radio operators are YLs. And we want to try to bring that out into our show too. We have YLs that watch our show, and we think this is going to be very interesting and a lot of fun having you on. Hey, I watch your videos, and it seems like every video you not only go to beautiful or historic places, but you also have fun. Now, I go to a lot of ham events, and I don't see people having a lot of fun, you know. But when I see you out there, it seems like you're having a lot of fun. So you must really enjoy the hobby.
Yes, it is. I like hobby. I like what I do. I like to travel, and I like to show a little bit for the other people from the different countries something interesting about my countries. How is she beautiful? How many beautiful places we have, and nature is also very nice. And I'm always try to change locations for the videos, and also I like to try different ham radio program, for example, Flora and Fauna or IOTA or something like this, and it is really very interesting to thinking about how to move from one place to the other, and yeah, it's nice, and I have a great fun. And I would like to show that it is a really nice hobby. You can learn a lot of information, languages, history, geography, and all of these things is, I think, very interesting and very important in our lives.
So I think you were born in Finland, is that correct?
No, it isn't. I was born in Uzbekistan.
Okay.
And during last 15 years, I live in St. Petersburg, Russia. Mm-hmm. Sometimes I am in Finland, but my city is St. Petersburg.
Oh, okay. And you're in St. Petersburg now. You've made that your home. And it's a beautiful city. And St. Petersburg, it's named after Peter the Great. Is that correct? And he was, yes. I guess that was many years ago. But it's a beautiful city, and a lot of history behind it there. So you've held calls. You've had ham radio license. You've had 3 calls. You've had a Finland call, I think, an OH call, right? Mm-hmm. Finland, and then Uzbekistan, and then now as R1BIG. You're a ham radio operator. You've got a wonderful story, and we're going to do some videos. You're going to join us from time to time and present some of your travels to these historic places and operations and so forth. And what are we going to see tonight? You've got a video that you made, and tonight, what are we going to see?
Tonight we will see my video from the center of St. Petersburg, my lovely city. And it was a very exciting experience for me because it was the first time when I was in the center of city, and it was at night. It was on the 24th of June. It is the shortest night in our region, and you know that in the summertime we have white nights. It means that it is not very dark, and the sun is sunset is very, very late in the night, and I was very excited because it was in the center of city, and I was worried about the police, but nobody was interested in my activities, and I was lucky.
Right.
Of course, I have my all papers, what I need, my license and my documents for the equipment, radio equipment, and everything was okay. But it was the first time, and I did not know what will be if someone from police come to me and ask some questions, but nobody wasn't interesting.
Well, I was going to ask that question after the video because, you know, it looks very strange, a person sitting out in a park with radios and wires in the tree.
Yeah.
Making some contacts, and I was just wondering, it has to look funny, it has to look strange, and I would think the police, if they were around, would surely ask you a question like, "What are you doing?" You know. So I'm glad you had your papers and everything's legal, and you're still with us. You're not in jail. So, all right. Well, let's take a look. Let's take a look at your video from St. Petersburg. And then we'll talk a couple minutes afterwards.
Okay.
Hello, my friends. Today I am in the center of my wonderful and beautiful city, St. Petersburg. I want to tell you more information about it. 3, 2, 1, let's go! It is Peter the Great who founded our city more than 300 years ago. St. Petersburg is a touristic destination. About 8 million tourists come to our city every year. Look at this beautiful night view on the Neva River. I really like to go boating, especially in such a wonderful warm summer evening. The view to St. Petersburg from the water is especially beautiful. By the way, it is the shortest night in the year. And I am going to install my radio equipment here and go on the air directly from the heart of St. Petersburg in this wonderful white night. Now it is midnight, but you can see it is not so dark.
Uniform Bravo 1, Alpha Oscar Alpha, stroke portable, is that Roger?
Roger, Roger. Thank you very much. Your report is 5 and 9, and my name is Raisa. I am running now from the center of St. Petersburg. QSL?
Okay, Raisa, QSL. Thanks for the 5-9. You're 4 by 2. My name's Steve. Sierra Tango Echo Victor Echo. QTH on the island of Bonaire in the Southern Caribbean. United Bravo 1, Alpha Oscar Alpha, stroke portable.
I have very simple antenna. It is dipole antenna on the trees in the center of city, in the center of very big city. QSL?
Yeah, okay, Raisa. Roger. I understand you're using just the dipole and you're in the center of St. Petersburg. Very good. Well, best wishes from Bonaire in the Caribbean. UB1 AOA portable, Papa Japan forward Delta X-ray 73.
73 and 88.
It's a portable, that is interesting, John. You should take that, guys. I didn't hear. Okay, who's the portable? Go ahead.
United Bravo 1 Alpha Oscar Alpha stroke portable UB1 AOA stroke portable.
Roger, get a United Bravo 1 Alpha Ontario America portable. You're 5 and 9 with me. 59, nice signal and a beautiful voice. Thank you very much for calling in. And my name is Hannes. My call is Delta Kilo 1 November Oscar. And now let's try with John. I hope John had a copy. Hi, stand by. John, go ahead. Okay, Uniform Bravo 1 Alpha Echo Alpha, I think. You're 5 and 7. 5 and 7 in Prince Edward Island, Canada. My name is John. Okay,
Canada.
over.
John, repeat your call, please. Repeat your call.
Your call again? Yeah, my call. Victor Yankee 2 Whiskey Whiskey, over.
Victor Yankee 2 Whiskey Whiskey. John, thank you very much. It's very pleasure for me to have a QSO with Canada. Victor Yankee 2 Whiskey Whiskey, please correct my call. My call is Uniform Bravo 1 Alpha Oscar Alpha.
Okay, yes. Thank you very much, Marisa. It's lovely to talk to you on the radio, and I have to tell you, I have a very good friend and a work associate named Marisa. So, спасибо большое.
Thank you very much, 73 and 88, John. So, my friends, today I have a fantastic night. I spent it in the center of my city, in this location. This is my portable equipment. And the propagation today was very, very nice and very interesting, like always. I had QSO with Canada, and I have QSO with Caribbean region. It's really fantastic. A few more words about St. Petersburg. We have 13 drawbridges. They are drawn at the night to let the big ships pass in and out of the Baltic Sea. Looks at this moment, a ship goes through the bridge. My friends, welcome to beautiful St. Petersburg. If you like this video,
I
please
thought
give me a
that
like,
it
and
could
don't
be
hesitate,
interesting
put
to
your
the
comments
police.
below.
And I took with me all documents, my ham radio license and my ham radio documents for the equipment, and just some people was interested and asked me what are you doing right now, and I explained them that it is our hobby. But of course you are right, absolutely, it looks very strange, because I sit and around me the equipment, and I speak in English in the center of St. Petersburg, and yeah, but everything was okay. Nobody was interested from the police, I mean, and yes, it was a great night, and it was so unusual to have the X station from island, Bonaire Island. It is so long distance from my point, more than 9,000 kilometers from St. Petersburg to Bonaire, to the island Bonaire, and it was really exciting to have this QSO, and also it was Prince Edward Island in Canada. It is the second DX QSO during these portable activities, and yeah, I every time think that it is so nice to have simple equipment, simple antenna, and you have chance to make a QSO with different countries. I'm so happy of it, and I had a great fun on this night.
Well, you know, the bands many times seem dead. There's no one on. But it seems like, and you know, I've noticed when we have contests, the bands are full. So that tells me we just need more people to be more active. And I've noticed when you get on the air, you have pileups. You have a lot of pileups when you get on the air. You open the band up. So do you enjoy pileups when so many people are calling you?
Yes, it is a big fun and great experience. Sometimes I want to have a simple QSO with someone and to speak a little bit more. But every time when I am on the air, I have a pile-ups and I want to be polite to everyone. And of course, I could not speak with one of my correspondents too long time, but I like it, and I'm very happy that when I feel the joy from the other side. It's really very nice because I know, for example, when I call the X stations and there is also pile up, and I could not call him. And one moment he answered me, and I'm so excited. And this moment I'm so happy. And I know that many people, I'm not at the X station, but I know that many HEMS operators are very glad to have a QSO with me, and I feel their joy, and it brings me a very, very nice feeling.
Well, you are very active in many things. I know you like things like fox hunts and contesting. Oh, hey, contesting. Let me just say this. I read where in 2019, the worldwide DX contest, you were #1 in Finland, right? You were #1.
It was my first experience when I was alone, like a single operator. Yes, it was a big result, great result for me. #1 in Finland, and I think 15 in
15 in Europe.
Europe, yes,
yeah,
yes.
And you were number 23 in the world. That's quite an accomplishment. Wow. Well, hey, I want to let everybody know about your YouTube channel tonight, and we're going to start having people check out your YouTube channel and your Facebook and all these things. Let me see if I can pull those up. You've got a great. Let's see. This is your Facebook channel right here. Guys, just go to Guys and Girls now. Go to Facebook and just put in YLRAISA, and you will find Raisa here, and this is all about her journey into ham radio, and she's got some very interesting things that she posts in her Facebook group. Let's see. Also, she has a blog. I think it's just, is it RAISA.blog? Is that right?
Mm-hmm.
Raisa?
Yes,
okay.
it's correct.
So everybody, please check her out, check her videos out, subscribe to her channel, and I think you'll really enjoy that. All right, well, Raisa, it is
so very welcome.
So it is such a pleasure and honor to have you join us on the show. Tonight is your premiere with us on the show, and we really thank you for being here. And we're looking forward to additional videos and discussions about the things that you do for ham radio. Thank you so much for being with us.
Tom, thank you very much. It was a great pleasure to me. And the next time we will tell about fox hunting too, and many other things which is interesting for us in ham radio. And I think that's the great idea that we have together. We have both. It is to promote our hobby, and everybody do it like he or she think to do it, and I think that if it will be more people, more active people in social media like we, we will have more new people in our hobby. And I hope it will be. And I know from my channel and from the people who wrote me the messages that they were interested in ham radio because they watched my videos, and I'm so happy about it. I wish you all the best, and to everybody 73 and 88. Bye bye.
Well, all right. Well, that was fun. And she's a fun person. She makes ham radio fun. And join her Facebook group, and hey, join her YouTube channel, YLRAISA. And join that channel. And she has many, many videos out there. This lady, she tackles everything. I mean, I saw her put up a long wire antenna over a lake. She's got a video of putting an antenna over a lake, and she's in a canoe and putting this antenna up. I've seen her shoot lions over trees. She's a better shot than I am with that big, I don't know what you call it. It's that real long stick-looking thing with the slingshot type thing. I think that's some commercial product out there, but she does it all, guys, and we're so glad to have her now with us on the show. And every couple of weeks, we're going to be bringing something new in from Raisa, and hopefully you guys will enjoy it there. So, Glenn and Alan, sorry you couldn't hear the audio in that first part there, but I guess we made it.
Yeah, I didn't realize that you were interviewing her kind of live and or live and recorded. So I thought you were still talking. I didn't hear you. So that's what threw me for a second.
Well, all right.
I fired up the web link and watched it off of YouTube.
Okay, well, great. All right. So, hey, Glenn, you got something you want to talk to us about tonight?
Sure.
What do you got, man?
I finally put something together. Well, part of writing the books and everything is you have to document what you've created. And of course, schematics are how we generally share our electronic designs. And of course, back in the old days, we had to handwrite those things out or use a drafting table, and, just painful. And there's a lot of software out there now that makes it simple. And of course, if you come up with a design that's popular, some people may want, a copy or to, have a circuit board because they don't want to do the wiring individually or whatever. And a lot of these packages will export that information to a file that you can ship off and have a PC board made. And so I've got a little PowerPoint presentation I put together here. And we're going to pick on one. Let's see. And too many screens up. All right, can you see this screen?
Yes, we can.
Okay. Tonight we're going to talk about Eagle Fusion 360 and Eagle PCB. This is what I use to create my schematics, although there are several others out there. And I really want to look at, I guess they call it KiCad. It's KICAD. KiCad, KiCad, whatever. So as we talked about, as you keep going and designing and doing things, there'll probably come a time when you want to share these designs or have a board made. I know in my case there are several boards that I'd like to make. The two big ones that are mostly used are Autodesk's Eagle PCB and the KiCad. At the end of the day, which one to choose, it's pretty much a matter of personal preference. You'll probably want to experiment with both. From what I understand, the KiCad is relatively easy to work with, and it's very full-featured. But the Autodesk it can be complex, but it's also got a lot of power behind it. So it's 6 of one, half dozen of the other. The KI CAD is what I call it, is an open source and therefore free product. It's a fully functional package. This thing can create boards up to 2.14 meters square. I don't think we have circuit boards that big anymore.
That's a big board.
It is. And you can also have up to 32 layers. I mean, you can literally make your own motherboard with this software, 32 layers. And you can get it for Linux, Mac, and Windows workstations. And my personal preference, because I've just worked with it for so many years and kind of just had to brute force with it, is the Eagle PCB. It's got a free version. It started out as open source and got bought by Autodesk. And just recently, they rolled it into their Fusion 360 package that we'll talk about in a minute. But the free version has limitations that they want you to spend money. They want you to buy the paid version. But it's still very functional and usable for what we want to do. It also runs on Linux, Mac, and Windows workstations. Recently, they made changes from the free version. It's now included as part of their Fusion 360 paid product, but they still leave us a limited free version of Fusion 360 for personal use. This also gives you access to computer-aided design and computer-aided manufacturing, CAD/CAM, as well as the Eagle PCB software. So you get a whole taste of their suite. But for now, we're just going to stick with talking about Eagle. To get it, first you'll need to sign up for a Fusion 360 for personal/hobby use subscription at autodesk.com, products Fusion-360/personal. This will allow you to download and install a limited use version of the Eagle. It limits you to 2 schematic sheets, 2 board layers, and a 12.4 by 12.4 inch board as compared to the 2 meter board on TCAD or KiCad. You can get full functionality from Eagle if you want to go with one of the paid versions, but for most hams, the free version will do everything that we need. Libraries is where all of the parts, specifications, pin layouts, everything you need to know about a part are contained inside these libraries. You can download and add additional libraries. There's a site called componentsearchengine.com and element14.com. That's where I got most of mine. And for the parts that don't exist, you can create and share your own parts and libraries, which I had to do for things like the lightning detector and some of the other Arduino parts that just didn't have a library yet. This is what it looks like when you first fire it up. You've got your libraries and all the other functions and your projects. And the project we're talking about here is the CW decoder project. I believe that was in my second Arduino book. And, or is it in the new one? Can't remember. I think it was in the second one. And so here is where you can actually select and add a part. And you can expand this out and get the different package types and everything and select and then put it onto the schematic board like this. And this is the entire schematic for the CW decoder. You just literally add part, grab the part, drag it onto the page, place it, and go. You add your wiring, and you've got it all set. From that, you can actually create a project. Either way, you can do it from the board view in a physical scenario or the schematic view. If you create one, Eagle will also automatically allow you to create the other for you. However, you're more than likely going to have to rearrange it at the end because it's just not that smart in terms of placement. I prefer to start from the schematic drawing, and once that's complete, if I want to, I'll create the board drawing and then rearrange the components and the circuit traces and everything as needed. It does have an auto route function to give you a basic layout of the board traces, and you can rearrange from there. The following slide is going to show you what a finished board would look like. I took the CW decoder board schematic that you just saw, used the auto route function, and I created a functional circuit board layout that I could actually ship off to one of the PC board manufacturers, and they would be able to etch that board for me. With Eagle, you can export this to a file called a Gerber file, and this is the standard interchange files for all the circuit board manufacturers, and they can create that board for as little as $2 a piece. And this is what the routed board actually looks like. And you can clean that up, square everything off and whatnot. And it automatically decides which side of the board. Since you only have 2 layers, you've got the top of the board and the bottom of the board. And you have the through hole, what they call a via, that you can pass the signal and avoid shorts and things like that. So that's just really Eagle in a nutshell. There is a great tutorial on sparkfun.com. They've got a whole series on Eagle at learn.sparkfun.com/tutorials and using-eagle-schematic/all. And you'll be able to run through all of those. I wish those had been around when I got started with Eagle. And it's really handy. The tutorials are very good. Of course, they've got a lot of other tutorials there as well. But Eagle was my personal preference, although I want to experiment with KiCad and a couple of the others down the road. But now you have the ability to get the tool you need to design and create your own projects and your own circuit boards if you so desire. And so that's where we went tonight.
Man, you got me really interested here. I use Eagle, and I've got this. The little tracker here is. I got the schematic. I got all the Gerber files, the board files, everything, and have these made. So, and I think there's a way to do it. Are you saying that if I've got the schematic, it'll actually draw this board from the schematic, and maybe I could just tell it to use 0604 size parts, and it would size it correctly?
No, you would have to replace each part individually with the 0604 size version of the component.
Because, the traces aren't big enough on this board to put the 604 parts on.
Well, you would just put it on a board, and you can size the board, but it would be a bigger board.
Yeah, I understand a bigger board. I'm sure interested. I'd like to double the size of this and maybe use the 0604 parts. That would make it so much easier.
Yeah. Now,
man.
But now, if that design was in Eagle, you can get the board file.
Well, I have it.
Yeah, I mean, not just the schematic file, but the .brd file, which is the circuit board file.
Yeah.
And then you can just start replacing components and do the auto route, clean up the routing, and fine.
I have all the files, that I send to have the boards made and everything. It's just I don't know how to manipulate them, So okay, I'll have to look into that when I get some time. Yeah. Okay.
Yeah, and in the chat room, they're talking about the 2 layers. Yeah, the 2 layers are top and bottom of the board. And because of the way the Gerber file's created, I don't think you can take 2 projects and merge them unless you're a really good guru. So, but like I say, for the Eagle, you're going to be limited to the 2 layers. If you want more, you're either going to need to buy the paid version or go with the open source KiCad.
They corrected me in the chat room there. It's 0603, and that's a little bit larger part. I'm using the 0402, which is so small. When I build this, Glenn, if I drop a part with the tweezers, or if I'm trying to solder on a board and it flicks out, I'll never find that part again. I mean, it's so small. So I'd like to try to do it. I really would. I can still manage these, but
I couldn't build one of those boards.
yeah, I'm gonna play with Eagle and see what I can come up with, you know. And what I've already got might make it easier just to try to convert it and, you know, expand it out a little bit.
Generally,
you know.
if you go through all the parts, a lot of those listings in the library, for example, you know, your resistors.
Yeah.
You know, your resistors come in various sizes, you know, the old through-hole resistors.
So I suppose like the SI5351, will it come in different sizes, or will I still be stuck with that small one?
You have different packages.
Yeah, but that would change up the layout of the board.
Versus TO5 and transistors.
Yeah, that would change the layout of the board. I'm looking for something I can just kind of easily, you know, expand out.
More than likely, it's going to be the same package type because they don't make a whole lot of different packages.
Yeah, yeah.
So,
okay.
But now, Chuck in the chat room saying finding the right part and package you want is one of the tough things. And for some of the oddball parts, that is correct. A lot of times I had to create my own part. Once you get used to the part creation process, it's not that difficult.
Yeah.
But generally, if you Google the part you're looking for, there's a very high probability that somebody's already created one and it's on a GitHub site out there somewhere.
Yep.
Or, you know, that's where I got most of my stuff is people would put together packages on GitHub and I'd Google and find the piece I wanted and grabbed it and got the whole library.
Yeah. Okay, well, hey, thanks for sharing that with us tonight, man. It's got me excited to work on that. Boy, Alan's got me working on scope probes, and now you got me working on Eagle. I got so much to do now. I'm going to be a busy guy the next couple weeks.
Yeah, I'm hoping I can get some time to get stuff going the next couple weeks myself.
All right, just let me make a quick announcement here, especially to all of our viewers out there and listeners. You know, we have shortwave listeners that tune into the show on 7490 kilohertz WBCQ, and that's out of Monticello, Maine. I think we're running low power up there. We're only running 50,000 watts. It's not a real high power station, but 50,000 watts. We are on shortwave, and we do occasionally hear from people in different countries that have tuned in. So shoot us an email if you're listening to us. Send it to Tom at w5kub.com. And also, I'd like to just ask everybody if you can, if you have not subscribed to our Facebook group, please subscribe to our Facebook or join our Facebook group. It's called W5KUB. We've got 12,000 hams in it, and there's always a lot of activity going on there. We'd love to have you. And on YouTube here, if you will, hit the subscribe button. That really helps us out if you hit that subscribe button, hit the notification button, and that helps YouTube to let other people know about our show. And our statistics show about 25% of the people that actually show up watching our show on a Tuesday night actually come to us from the little thumbnails over on the right side of YouTube, you know, that says we recommend this video for you, a similar video. So about 25% of our people come from that. All right. Hey, I want to talk to everybody very just briefly about some, backup power. It's important, and especially for Glenn and me down here, we lose electricity down here in the sticks a lot, especially when we get ice storms. Ice storms are what kills our electricity down here. Guys, you may have known, I mentioned, I've ordered a 22 kW gen rack to put in the house here, to all house generator. I paid for this thing in July, the first week of July. I haven't got it yet. And they're estimating now that the delivery is going to be the 27th of December. So I won't even get this for Christmas. I bet you I don't even have it in January. But, the supply chain is so messed up right now in the world here that, it's just, you got to grin and bear it. There's not much you can do. But in the meantime, In the meantime, you know, I do have a generator that I can plug into the house here. It's a gas generator I can crank, and you know, for an emergency, and run the whole house with it. But I have to go out there, I have to hook it up, I've got to drag it out, I've got to crank it and all that. It's a gas. Now, this Generac here is going to be natural gas. So it'll be hooked to my natural gas meter out here. And, you know, it's going to automatically start all by itself, automatically switch with transfer switches and so forth. And so that's going to be neat to have whenever I do get it. But in the meantime, in the past few years, I have kind of made a poor man's backup to keep me on the air and keep the computers running. And you know, probably many of you are familiar with the little UPSs. This is a little APC 650, I guess, volt amp UPS system. It's roughly 650 watts, and you know, it has inside there. It has one battery. It has one little battery. Let's see if I can find a battery. Yeah, it's got a, well, that's an 18 amp hour battery. But when this thing goes into backup, it's usually drawing more than that. And if you have a standard UPS system, you know that it only gives you enough time to shut down your computers. That's basically what it's for, just so you can safely shut down your computers. This particular one, this 650, is one that I have put, you can see the red and the black wire there. I have taken out the internal battery and ran a cable out for an external battery, and I'm using a much larger battery there. This is what we use on the video cart when we move around, like at Dayton or Huntsville. And we have laptops running and Wi-Fi running and all kinds of things going on the cart, running off 110. So this battery with that little 650 UPS, it'll actually run you know, an hour and a half, 2 hours, pretty easy there. The company I worked for used to throw these things away basically when a battery would go bad. Or they just didn't need them anymore, or they upgraded to larger units. These were basically junked out. So if you look around, you might can find you a UPS system for free. If not, you can find them on eBay. Here's a 650 on eBay for $20. Now this is without the battery, but you don't need the battery. Now, so that's what I use on my roll around cart. But here at the house, I did something kind of special and unique here at the house. Out in my shop, I have a 1500. Basically, it's a 1500 watt UPS out there. This was made by Triplite. And let's talk a little about it first. So there's a front view of it, not much to see. There's a side view. Let's see. Okay, 1500. It's a 1500 XL, and it's roughly 1500 watts, and that's quite a bit of power actually. You know, when you need it. Now, if you go out to try to find one of these on eBay, it's going to be much more expensive, even used. Here, this is $160, but it comes with 2 new batteries in it, or 2 good batteries in it. You might can find one much cheaper without the batteries in it. Now, this particular one here is a 24 volt system, 24 volts. So they use 2 12 volt batteries in series, and I think these are 7 amp hour batteries. These are 7 amp hour batteries. So you can see once this thing goes into battery backup mode, it's going to be pulling 20 amps. And those batteries are going to last you about 10 minutes. I mean, I'm surprised at how quick a UPS system actually runs down. So I did the same thing. On my my 1500. And I had my 1500 out in my shop. And I put 4 6 volt deep cycle golf cart batteries in series, and this gives him my 24 volts. This particular UPS actually had a plug on the back for external power. So I just basically plug those in. You could remove the batteries and you could run the wires out to your batteries. Now, these batteries here, these batteries will let you, and let me just say, so I've got the batteries outside, and the 110 volt, I ran Romex from my UPS through my attic and down into the ham shack, into my office, into my family room. So I have receptacles in the wall in those rooms. I have a number of computers plugged in that run all the time. I have my internet router and modem plugged into it. I have the TV plugged into it. I have a lot of things that are plugged into it, and it's got about 60-70% loading. The 1500 watt UPS does. So let me show you what I got there. I picked me up some Trojan golf cart batteries. These batteries are about 80 pounds a piece. So, you know, and they're, I think these are 225 amp hours. So, you know, we're going from a 7 amp hour system to a 220 amp hour system. So I got 4 of those batteries, and the guy I got them from at the battery place gave me a charger. He says, "You're going to need something to charge those batteries with." And he gave me a big golf cart charger right there. And I said, "Well, I think the UPS will charge them." He said, "No, there's no way. It won't charge these." Well, that's not right, because even though this charger will put out 20 or 30 amps and charge it very quickly, the UPS will charge it, but the UPS only puts out about 1.5 amps. So if I have a power outage here, and let's say I use, you know, I don't know, if it draws 20 amps, and let's say we're down for an hour, I use 20 amp hours of power. Well, that 1.5 amp charging is going to take me 20 hours to charge that up. And you know what? We have outages so infrequent that the UPS charger is actually keeping those batteries charged and up where they should be. I took me a little off the internet. Everybody has seen these little digital readouts that read out voltage and current. Built me a little box up and put it in the line. It goes out to my battery right here, so I can always monitor the voltage there, and I can see when the charging comes on. I can see the charging current there, and so forth. So outside my shop, if the 2 red wires there go out through the window to behind some bushes outside my shop, and I built a little box up like this, a little weatherproof box up to hold these batteries. And there they are again right there. You know, we went from probably 15 pounds of batteries to about 300 pounds of batteries. So you can see the capacity there. We greatly increased the capacity there. So I just wanted to let you know that that's kind of what we use here. That will run all my computers, my TV, my internet. That'll run everything about 10 hours. I've got 10 hours, and by then usually the power's back on, or I can get my generator out there. And once I get my generator running, it starts recharging the batteries through the UPS. And hopefully I'll get my 22 kilowatt generator maybe as a Christmas present and get it installed. But that's what we're looking for right there. Yeah, the UPS charger will take forever. Like I said, if you pull 20 amps for an hour, that's 20 amp hours. And at 1.5 amps, it's going to take you, what's that going to take you? About 15, 16 hours to charge it back up. So, but it will charge it, and it does keep it floated, and it keeps the batteries charged. If I want to do a quick charge, I could always use the if I guess, where's my picture at? Can't find my picture. Well, there it is.
Golf cart charger?
There it is right there. I could always use the golf cart charger if I need a quick charge. Like I say, that's about 20 or that's That may even be a 40 amp charger right there. You know that typically charges those golf cart batteries pretty quick. So, but I've never had to use that charger. So anyway, that is the story, and I'm sticking to it.
You know, one thing you mentioned about being able to find those at Hamfest, Swap Fest, and things like that. Most people don't realize that you can change the batteries, or they don't want to bother trying to find those batteries because they're hard to find if you're looking at a local Walmart or whatever. But go online, you can get them, you know, dirt cheap for those 7, 8, 9 amp hour batteries. And you're talking like for one, it's like $18.
Yeah.
My UPS uses 4 of those, and it's a 1500. But somebody just gave me the UPS because the batteries died and corroded all the terminals.
Yeah.
I just put new spade lugs on it, and poof, I've got a brand new UPS. So 90% of the time, if you see one for sale somewhere that's dead, no battery or whatever, 90% of the time, the only problem with it is the batteries or the connectors.
And you know, this is a trip light I've got that I have here, the 1500. Prior to that, I had an APC in here. Some people, you know, there's some rumors about APCs have issues and so forth. But anyway, I thought my APC 1500 went out. Actually, it was my batteries that had gone bad, but I didn't realize it. And I took that 1500 watt APC UPS and I just stripped it. I tore all the parts out of it. And then I realized, oh man, it was my batteries.
Exactly.
So that's when I went out and bought a 1500 watt off eBay, and I think I might have paid about $100 for it. Someone's asking what's the cost there. I paid about $100 for that big UPS. The batteries, I have a friend who has a battery company, and I bought those batteries for $25 each. So I've got $100 in the batteries. He gave me that charger, which I'm not having to use. So, you know, and it's worked out really well here. When we do have an outage here, boy, all the computers, everything stays on. Everything just works fine. And, we're real happy with that.
I'm the same way. I didn't do it like you did. I've got a separate UPS on all my critical stuff. So that if the power goes out, I can still watch TV and everything. The computers are on. And, you know, I probably have about 25 to 30 minutes of runtime with the standard batteries. So plenty of time to do whatever I want to do and shut down gracefully or what have you.
You know, I was reading the chat room. At my other home, I had a similar UPS setup, and I think it was an APC, but I did have the batteries outside. Instead of 4 6-volt, I had 2 big 100-pound 12-volt batteries.
Yeah, I've seen those.
Yeah,
big
you know, like we got it at work. You've seen them. You know the batteries I'm talking about. So I came home. I mean, we were out of town, so I came back one time and opened the top of that box up. Those batteries had actually melted. They were all that plastic. They had basically melted and almost just stuck together. I mean, it was. I'm glad I didn't have it in the house. And and that's the reason. That's the reason that these are outside, particularly for the gas they give off as they charge. And you know, they seem to function very well. I just built my little box and put some insulation on it, and I just check the water every few months, and it's good to go. And, you know, when I get my generator in, I'll still keep that UPS running. And all the things I have in it will continue to be backed up.
You know, one of the big things, and they're kind of talking about it, and you kind of talked about it, those little 7 amp hour, 8 amp hour batteries, they are sealed lead acid batteries.
Yeah.
And as they age, they tend to dry out. And then they'll split, or they'll expand, bulge up first, and then split, and then they'll dry out. And of course, when they split, you get that wonderful sulfuric stench. And that's how you can tell that you've had a battery go out on you.
Here we go. You can get the UPS at Goodwill. I mean, just check it there. People buy ham gear there. I can't believe it. I don't know that we have it here where I live, but
I don't think I've ever seen ham gear at a Goodwill store.
you know, I see it on Facebook all the time. People picking up ham gear or shortwave receivers and some nice stuff out there.
There is some good stuff if you like. They've got an online auction site.
Oh, really?
And if you are patient and, you can find some good stuff. I'm not patient. I go straight to eBay and do buy it now.
All right, I'm just checking it out here.
But, talking about parts, I had parts come in literally day before yesterday that I had ordered back in September. So.
Yeah. Someone mentioning they got a solar panel and they charge with solar. I've got, and I'm not using it. I have one of these large solar panels you see on the side of the road in these big solar farms. It's about 5 feet tall and a few feet wide.
Yeah.
It's 28 volt at 9 amp. It's pretty hefty, man. It is really hefty, and I've got one of those. I've just never hooked it up to anything. Never really had the need to, but you got to be careful with that thing, man. You don't want to carry it out in the sun and get the lead shorted or anything.
Yeah.
Yeah.
See, the problem is if you are dealing with something like an ice storm, it's winter, so you got the short days. It's probably overcast, and you're in an ice storm, so you're not going to have any sun. So you're pretty well out of luck until the storm passes.
Yeah.
And the same with a thunderstorm or, anything else, in the spring, severe thunderstorms. You're not going to charge with the thunderstorm overhead.
Yeah. Somebody asked me, what does this Generac cost? This is the 22,000 watt, and it will run the entire house. We have 3 central air conditioning units here at the home, but it'll run everything. If you go to Generac site, they tell you, the average price to have one of these installed is like $6,000. Okay. Well, I tell you, that is not true. And I shopped around, and the first bid I got from the people to put the same one in, the $6,000 I was expecting, they came in at $12,000. And I checked with a number of different people. Everybody wanted $12,000 to put it in. And I told them that's too much. I said, the Generac website says the average cost is $6,000. What's the deal? So they called Generac, and Generac told them, that's an old website, and and it's a little more than that now. So they actually reduced my price to like $11,000. 11.5 or something. I got this through Lowe's, by the way, and this included everything from plumbing, the gas lines to be hooked up, all the new wiring, the transfer switches and so forth. It included everything. So they came down to about 11,000. I said, well, you're making me happier, but still no go, So they finally came down. I got them down to an even $10,000, and they said, well, it might be a couple months. And an electrician said, no, it won't be a couple months. He says that particular model, you don't have any problem getting it. But right now, everybody is out of them. Nobody's been getting them. I've been getting updates, and my update I got this past week was delivery now of 27th of December, which I'm sure won't happen.
No.
And I bought this thing the first week of July. So, man, we're talking almost 6 months here. It may go 7 or 8 months, easy.
Yeah. Oh, I'm just thankful I got all my major house projects, renovations and stuff done before the price of wood went up.
Yeah.
My gosh. Yep. I hear, 2x4s.
They're asking if you do the install yourself, can you do it for 5 or 6? I think if you can do it yourself, no permits, no inspections, that type thing, you probably can. I mean, I think I would be capable of doing it. It's pretty simple, and there's even videos on YouTube showing how to install the Generac. I think you could do one for $5,000 or for $6,000. The thing is, everybody, I mean, I think the electrician wants $3,000 to do his wiring. Well, he does everything he gets the plumbing done and the wiring and the gas and all that. The permit, the city permits just to get it done is like $300 just for the permits. I wouldn't try it myself, something that big in the city here. It would probably not be worth doing.
I don't like playing with anything that involves gas. Electricity is one thing.
Yeah.
Messing with gas and worrying about leaks and getting it shut off right, doing it right, no, that's not me.
Yeah. So yeah, you can do it, but hey, everything is getting so expensive now, and of course the wire size you got to run is like, I don't know, double alt or something. I mean, this big stuff, about the size of your thumb.
Yeah.
I just think the few pieces of wire he has to run, the wire was like $300, man.
Yeah, I mean, you're talking a 22 kVA box.
Yeah,
I mean, that's some serious power.
Yeah. Okay. Well, you know what? We've just about filled up the show tonight. Let's see. It's a little power system. Okay, Colin says there in Australia, a 22 kVA home standby diesel generator is Australian $15,400. Now, I don't know.
Yeah, what's the exchange
I don't know what the exchange is, 15,000. Somebody look it up. What's the exchange? What is 15,400 Australian dollars in US dollars? It might be a little bit more, actually. Yeah, I've got 200 amp service here, so that's what they'll put in. If we have an earthquake, we'll probably lose natural gas.
Yeah,
probably. But we've never lost natural gas before. We always lose electricity, but we've never lost natural gas before.
Of course, my heat is natural gas, but of course the fan is electric, so I'm pretty well out of luck.
Well, and that's why my generator out there, I don't run, when I run I've only got a 8,000 watt generator. I don't run things like the air conditioning systems or the electric range or the oven, but it definitely will run the blowers in the furnaces.
Yeah, that's
to keep
all that really matters.
To keep you warm in the wintertime.
Yeah, you'll get your hot water and you'll get your hot air.
Let's see. If I did the install, I could leave the microscope in the shop. I guess that's what it.
With 200 amp service, I don't think you'd need a microscope.
Yeah. Oh man. Well, at least the gas is outside. If I had a leak, it wouldn't. It might be a little better. I was saying we're about 10 minutes toward the end of the show here. We covered so much tonight. We didn't really have time to open the phone lines here tonight or Zoom for people. I hope you enjoyed the show, and hey guys, if you will, man, send a note to Raisa, and let her know that you enjoyed having her on here. And I think it's great having her on here from over there. It helps bring up some international flavor to the show. It's something I've been wanting to do for a long time, and she has so much energy and so much fun with the hobby. And most of us hams, I don't know, us old guys, I guess we're running out of fun now. It's work to carry that thing to the table and all that, So.
Yeah. Here's your exchange rate, by the way.
$11,194. Okay, well, it's very similar in price.
Yeah.
And that's for diesel, and this will be natural gas. Now, I know natural gas is different than LP gas. I think the orifice is different or something. But I've been looking at this generator, the parts and everything, and it looks like there may be some type of switch or something on a generator that you can select LP gas or natural gas. Now, if that's true, if we ever lost natural gas, I could take an LP gas bottle out there and possibly make it work.
Well, Keith is saying the orifices are smaller for liquid propane.
Yeah, I don't know if that if that switch does it, or if you have to change something else. Maybe you have to do multiple things. Probably.
Maybe there's a different feed connector.
But I'll tell you, you take a little one of these little gas grill bottles out there, the 30-pounders. I bet you it wouldn't last very long on there.
No.
It would probably suck that thing down pretty fast.
No, you'd have to get one of the big, huge
I have to get one of those 8-foot tanks, out there.
Yeah.
Yeah. Oh, man. Oh, let's see. Let's see what else we got going here in the chat room. Yeah, I think if you send a note to Raisa, I think she'll reply back to you. So everybody say hello to her, send her a note, and that would be cool. Or go to her Facebook, join it, or join her YouTube. Leave a comment on YouTube, and just mention Amateur Radio Roundtable. I think she'll get a big kick out of it. Natural gas is going up. Yeah, hey, it's going to go up about 40% probably this winter. But hey, when you have a power outage, and we have had some, over the years, this area has had some serious power outages. And I know down in Mississippi, back we had a big ice storm, and we lost all the big steel towers and all the high tension lines. They all fell. And there were people here, even in Memphis, that didn't have electricity for more than a month.
Oh, yeah. I remember 1993, 4, when I lived in Birmingham. We had that big
That's the big one.
storm.
I think that's the big one that came through here. Yeah.
And interesting, my power was only out for about 2 days, but the apartment in the same physical building as me, but across the hall, was on a different feed, and they were out for 3 weeks.
Oh,
so, yeah.
Well, that's like electricity is here.
We ran an extension cord across the hall.
That's like electricity is here. My street's a U shape, and everybody loses power on my side of the street, but across the street they keep power, usually. But those are minor outages, nothing big and serious like I'm trying to prepare for with the big generator. We can always live a day without electricity, but I would hate to think about a day we'd have to try to make it, a week without electricity. Yeah.
But yeah, I mean it's going to be an expensive winter one way or the other, either electricity or the gas or whatever. Yeah, I'm just thankful that I only have to drive to work 2 days a week instead of 5.
Yeah. All right. Hey, everybody listening out there. Hey, thanks for joining us tonight. We really appreciate having you. Thanks for listening on International Shortwave, WBCQ on 7490. Join us on Tuesday nights, and you can watch the video and join us on the chat room and be a part of the show. We'll probably open the phone lines up next week. We're going to have Raisa. I've got to get that name down right. It's Raisa. We're going to try to have her in here every other week with some exciting historic operation somewhere. And hey, if you go look at some of her videos, you're going to see her climbing Russian towers and operating from the top of towers, lookout towers, to old forts and lakes, all sorts of things. We're so glad that she's joining us here. All right. Well, any last words, Glenn?
No, I'm pretty much done with everything tonight.
Welcome to our new, all the new people that maybe are in the chat room that joined us tonight. We really appreciate it. Thank you, everybody. Good night to everybody, and we'll see you next week.